Welcome to the video on perfect squares. What are the characteristics of a square? What I want you to do is think about what you already know about a square from elementary school. And now what I want you to do is think about what you know and what you've already learned about an exponent. So with an exponent, we know that it shows repeated multiplication. We also know that the big number is the base and the exponent is the smaller number in the corner. The exponent tells us how many bases we have. So in this case, 2, there are two 2's. So if this was 3 to the second power, there would be 2 3's. So what makes a perfect square? I want you to think about what you know about a square. Okay, hopefully you know that a square has 4 sides. Hopefully you also know that a square has all equal sides. So now looking at these pictures, I want you to decide which one would be considered a perfect square. Just take a moment to think about that. All right, hopefully you chose this one. This one has all equal sides. There's 1, 2, 3 squares this way, 1, 2, 3 squares that way, as well as this side and this side. It is the only one that has all equal sides. A perfect square is a number made by squaring a whole number. So, in other words, we're taking a whole number right here. A whole number does not have a decimal or a fraction. And we're squaring it. So we're saying that there are 2 of those numbers. So basically what we're saying is we have 3 for the side and 3 for the bottom. And we're going to say 3 times 3 equals 9. And that's the 9 squares we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is a perfect square. So your learning target for today, you will be able to identify a picture of a perfect square, determine if a number is a perfect square, and find the solution for a perfect square that is written in exponential notation. You will also learn the pattern for the powers of 10. So let's take a look here. What we want to do is create a 1 by 1 square. So what that means is we are only going to take up one box here. So we have a 1 by 1 square. 1 times 1 equals 1. Okay, see here, we have 1 square, and we have a 1 by 1 square. Alright, the next one is a 2 by 2 square. So we would have a 2 by 2 square. So we have a 2, a 2. 2 times 2 equals 4, and we have 1, 2, 3, 4 squares here. Okay? The next one is a 3 by 3 square. Okay, the next one is a 3 by 3 square. So what you would do, take 3 boxes, and now we have 9 total squares. Okay, 3 times 3 equals 9, or 3 squared equals 9. Next we can do 4 squared, or 4 times 4, so we should get 16 squares. We can do a 5 by 5 square. See here we have 5 by 5, so we have 25 squares. We can have a 6 by 6 squares, so now we have 36 squares inside of here. We can do 7 times 7, which is 49, 8 times 8, which is 64, 9 times 9, 81 squares, and we can do 10 times 10, which is 100 squares. So what I want you to do is go ahead and fill out your notes. A square has 4 equal sides. When we talk about perfect squares, we are referring to the area of the square. And the area is how much space is inside of the square. And we find the area by multiplying the length times the width. You are multiplying a number by itself when you have a square. So what I'm going to do is go ahead and go back to the last picture. So we have the length, which is 10, and we have the width, which is 10. And length and width can go either way. So you have the length and width, and both are 10. So what you're saying is 10 times 10 equals 100. You can go ahead and pause the video here if you are still filling out your notes. Alright, so here are some more pictures of different representations. So this would be a 2 by 2, and it has an area of 4. This one's 3 times 3, has an area of 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. So what we're going to do is we are going to go ahead and fill out this part of our notes. So there are 20 perfect squares. So go ahead and write perfect squares. And these are the 20 that you would need to be able to identify. So what I'm going to do is I'm going to go ahead and pause the video and I'm going to fill this in. While I'm doing that, I would like you to go ahead and fill it in as well. You would need to pause the video at this time. Okay, as you can see, I've went ahead and I filled in all the perfect squares. You should be able to automatically recognize these as soon as you see them. Now you will get a calculator on your quiz, test, and SOL on perfect squares. But if you have, say it gives you just 225 and it says, is that a perfect square? You need to be able to say yes or no. So there are two ways to figure out if 225 is a perfect square. You could do trial and error if you don't have it memorized. You could say, well, 12 squared is this, 13 squared is this, 14 squared is this, until you figure out if 225 is a perfect square. Or you can use what's called the square root button on the calculator. So if you use the square root button, it looks like this. You can put 225 and hit the square root button, and then it will tell you, well, it is 15. If you get a whole number, then you know that you have a perfect square. So go ahead and pause the video if you're still filling this out. Otherwise, go ahead and move forward. So 1 is a perfect square. You'll see I added a black dot over here. Students do quite frequently forget that 1 times 1 is a perfect square. And I do want to point out the most common mistake I see is that students want to just say 5 times 2 equals 10. 5 squared does not equal 10. That's why this line is going through it, because 5 squared means 5 times 5. 5 times 5 is 25. Okay, here are the perfect squares filled out up to 10. Here they are up to 15 and up to 20. One good technique for learning your perfect squares would be to create flashcards and study them. You are going to have a quiz on this soon, so please make sure you are studying this. Alright, the next thing we're going to go over is your powers of 10. These are going to be written using exponents as well, and you're going to see a pattern here. So 10 to the power of 0, anything raised to the power of 0 is just 1. Okay? 10 to the power of 1 is 10. 10 to the power of 2 is 100. 10 to the power of 3 is 1,000. 10 to the power of 4 is 10,000. 10 to the power of 5 is 100,000. 10 to the power of 6 is 1,000,000. This should say 10 to the power of 7. 10 to the power of 7 is 10,000,000. Okay, so the power of tens create a pattern. I don't know if you noticed the pattern while I was going through that. But so 10 to the power of 0 has 0 zeros. So the answer is just 1. 10 to the power of 1 has 1 0. The answer is 10. 10 to the power of 2 has 2 zeros. 10 to the power of 3 has 3 zeros. 10 to the power of 4 has 4 zeros. 10 to the power of 5 has 5 zeros. 10 to the power of 6 has 6 zeros. And 10 to the power of 7 would have 7 zeros. So the exponent, or power, tells you how many zeros you have after 1. Now these exponents work the same way. This is 10 times 10, which is 100. 10 to the third power would be 10 times 10 times 10, which is 1,000. 10 to the fourth, you'd be multiplying 4 tens. So powers of 10 work the same way, but there is this little pattern where the exponent tells you how many zeros you have. Remember that 10 to the third power means 10 times 10 times 10. The exponent tells you how many bases you are multiplying together. So some questions for discussion are in your notes. I want you to answer these 4 questions, and we will go over those tomorrow. All right, and then here's some review questions. The first one's a review question from last class. I want you to go ahead and complete those. And then go ahead and complete this question. It's new today. And we will go over these 4 questions as well as these 2 questions next class.